the growth in the table is tripled at each whole year. So we start with this value at year 0 of 2. That triples to be 6 at the next whole number. That triples to be 18. And that triples to be 54. And that triples to be 162. And we want to then find these other values in between. I'm going to start actually by finding the explicit equation. The explicit equation is going to be our bacteria, which I'll call B, and the years we'll call Y. So our bacteria as a function of Y is our starting value 2 times the growth factor of 3 raised to the Y. And then we can see that 2 times 3 to the 1 is equal to 6. And 2 times 3 to the 2 is 18, and so on. And we can actually then fill in these other spots by using that exponent. And there's an exponential form, which I'll write here. So 2 times 3 to the 1/2. And then 2 times 3 to the 3/2. And 2 times 3 to the 5/2. And 2 times 3 to the 7/2. But there's also the root form. So to get from 2 to 6, we're multiplying by 3. But if I only want to do half of the required multiplication by 3, that is the square root of 3. So 2 times the square root of 3 is that number there and there. And then if I multiply by another square root of 3, I get 2 times 3, which is 6, and that puts me there. And then I'm going to multiply this next one by the square root of 3. And I could just take 6 and do 6 times the square root of 3. Okay, and so each time we go half of that multiplication that we need, that's the square root of 3. And so this next one is 18 times the square root of 3. And this next one is 54 times the square root of 3.